Let's scroll down and we begin to see, hey, what's after the command line in an HTTP request? Yeah, the header lines. So header is another field in the request struct. This is where most of the header lines are stored. The type of the header field is a struct itself. It's the header struct. We didn't see the code of the header struct, but it's actually well explained in the comments here. So the header is a bunch of these mappings between a string and an array of strings. Now recall what these header lines look like. You have what? The name of the header line and then the values of the header lines. So you ended up having what? A bunch of these mappings between a string to an array of strings, because the name of the header is a string. Values are a whole bunch of these strings as well. Okay, so given the example above here, so this is a request containing 5 header lines. So the accept encoding gzip deflate is a mapping between accept encoding a string, gzip a string, deflate also a string. So this is an array of 2 strings. So the accept encoding header line is a mapping between a string and an array of strings. Similarly, for the accept language header line. Now, foo is the name of the header line. Bar, the value of foo. F being small, OO being capital. There's another header line, which is also a foo, but the OOs are small. Now, in Golang, HTTP requests header names are casing sensitive. So F big O, F small o, they are actually classified into the same header name. So in the header field, it will be just one string, FOO, capital F, small oo, and then 2 values, bar and 2. Okay. Now in the header field, okay, the first string here indicating the header name will always keep the first character capital. So A and E are capital. A and L for the second header line also capital. Foo, yeah, F being capital. All right, so the first character of the words will be kept capital. That explains how these 4 header lines are stored. But what about host being example.com? Yeah, it is quite interesting. The host header line is actually stored as a field itself. So request structs has a separate field called host. That is also a string that is just to store example.com. Okay. There are other fields also a bit special. Content length is also a header line, but it's a separate field itself. If we scroll down, you see right there, content length is a field itself, although it's a header line. And it's now an integer of 64 bits, so it's to store the data size. Further down here, you see host. Yeah, it's of type string, so this is where the example.com is stored. Now with the knowledge about the request struct, we can now go back to the example code here. So what we're doing here is to call the re-request API defined in net/HTTP. What it does is to take messages coming in from the socket, right, and parse it automatically and generate the request object. And the REQ here is the variable storing that object. And we now know the struct of that object. So we see req.host should be referring to the web server the HTTP request is going at. And req.method here should be giving us what? The method in the command line of the HTTP request message. Now the only line that is still not quite clear for you is just this. The last FMT printf. So what we're printing here is the value of the user agent header line. So user agent, and this is an API associated with the request object. So inside the request struct, we define the fields of the request object. But outside of that struct, there are also a number of these APIs defined for the request object. So if we go back to the source code, so this is where we were. Yeah, host is a field in the request struct, and which stores the host name of the web server the request is going at. So if we scroll down, we'll see other fields in the request struct. Okay, trailer, remote address, request URI, TLS, cancel, etc. CTX, it's also a field, okay, and it's of a spatial data structure itself. And finally, the end of the request struct. Okay, so inside the request struct, essentially a bunch of these fields. Okay, some of the fields very simple, string type, integer type, but some of the fields more complicated. Okay, and after the request struct, we begin to see a bunch of these APIs defined that are associated with the request objects. Okay, so context here is to return. The CTX field value of the request R here. Okay, so R here, yeah, is just the request. So it's actually returning request's CTX field value. So we go down further. With context is yet another API associated with the request. Similarly, cloning of a request, proto at least of a request, and finally here, user agent. It's an API also associated with the request. What it does is to simply return request's header field. Okay, and by calling the get API defined for the header struct. And what it does is to do this. Search through all these mappings between the header name to the header values and get the values for the header name user agent. So essentially, user agent API here associated with the request object is returning the value of the user agent header line. Hey guys, look to the left. This is already what? Line 406. And we started from where? Line 108. Without you knowing, yeah, it took us some time, but we have explored 300 lines of code already. We know what are the fields in the request struct, right? We also learned there are actually some APIs conveniently available to allow us access to some of the values in other part of the HTTP request messages. What you need to do next is just to explore further. And let me take you back to the description of pa7. So what Polly has demonstrated in the past 10-ish minutes or so is to show how she discovers ways to access method in the HTTP request messages. And for example, the values of the user agent header line. What you need to do now is to explore further. Okay? Look for ways to access the token values required for the assignment, which is what? The URL field, that is the second token in the command line, and you need to find out the path name and the file name. So that provided these together, you could see in the file system whether the file does exist. If it does, tell the file size. If it doesn't, print file not found. Taking on the assignment, this approach is going to take some time because you're reading source code there. But the thing is this, it's also good investment because after some exploration, you will know the request struct very well, the associated APIs very well. So if you need to write another program that accesses HTTP request messages coming in from a socket, your code can be very brief, The effort is usually just very incremental. So the amount you need to spend next time is very short. And gradually, it's not going to take much time for you to find out what is the specific values you're looking for to process these HTTP request messages. And you know what? You don't really need to memorize the HTTP request message format, because by calling request, that is already done for you. You just need to know the request struct and the APIs, okay, and the related structs. Taking on this assignment, this approach is going to take you some time, yes, because you're reading source code that you are not familiar with. But the thing is that the more you try taking this approach, your knowledge builds up. So by the time you know the request struct really well, the associated API really well, when you need to write yet another program to access specific tokens in the command line or specific value in the header line, it's going to be a piece of cake for you, and the code is going to be very brief. Okay? You don't need to memorize HTTP request message format anymore, because all you need to do is just to call read request. Okay? So this is an approach that requires time early on, but things go easy and quick afterward.